points and extrema. Optimization is an application of mathematics where one searches for a maximum or a minimum quantity given a set of constraints. It's a big thing in calculus. Critical points are those points on a graph at which a line drawn tangent to the curve is horizontal or vertical. So a tangent line is a line that touches a curve at exactly one point. It just brushes past it and keeps going. So this would be a very bad drawing of a graph with a horizontal tangent line. We could also have something that looks like this, which is going to have a vertical tangent line at some point. And that vertical tangent line is going to go through it because there's no way to draw it that doesn't go through it. A polynomial can have 3 types of critical points. A critical points can be a maximum, a minimum, or a point of inflection. So the maximum is where your function starts out increasing and then changes to decreasing. The minimum is where your function starts out decreasing and changes to increasing. And a point of inflection is where your function flattens out, has a horizontal or vertical tangent line, but doesn't switch from increasing to decreasing or vice versa. It stays constantly increasing or constantly decreasing. All right, so here is a maximum here at point P. You're increasing up to P, you're decreasing after P. Horizontal tangent line. Here you're decreasing up to point P and increasing afterwards. You got a horizontal tangent line, that's a minimum. Here you've got a vertical tangent line, but your function is only increasing. It doesn't switch, so that's a point of inflection. The greatest value that a function assumes over its domain is called the absolute maximum. Likewise, the least value of a function is the absolute minimum. The general term for maximum or minimum is extremum, plural extrema. So this function has an absolute minimum here at like -1/2, 0. This function has an absolute maximum at -1, 2. This function does not have an absolute maximum because the end behavior goes to infinity. This function does not have an absolute minimum because the end behavior goes to -infinity. If I were to restrict the domain and ask for the absolute minimum on the domain -2 to 1, then it would have an absolute minimum, but only if I restrict the domain. Functions can also have relative extrema. Relative maximum may not be the greatest value on the entire domain, but it's the greatest y value on some interval of the domain. It's where the function switches from increasing to decreasing. A relative minimum is going to be where it switches from decreasing to increasing. So it's the least value on some interval of the domain. Finding extrema of functions is a huge part of calculus. Right now, we're mostly going to do it by graphing, because you don't know how to find tangent lines yet. That's a thing that you will do in calculus. So locate the extrema for the graph y equals f of x, name and classify the extrema of the function. So we have a local minimum here at -3, -1. We have a local maximum at 1, 5, and we have an absolute minimum at 4, -4. There is no absolute max because the end behavior goes to infinity. Use a graphing calculator to graph f of x equals 5x to the third minus 10x squared minus 20x plus 7, and classify its extrema. So we're going to graph the function. So if I switch to my calculator, x to the third minus 10x squared minus 20x plus 7. And if I graph it, the function looks like this. So it's a cubic function. It has a local maximum right there, approximately. It has a local minimum about there. Hey, look at that. This even tells me minimum at x equals 2. See how close I have to get for it to tell me what the max is. Yeah, well. So we graph it. You can find the local max and local min. No absolute max because the end behavior goes to infinity as x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity, so no absolute min either. If you know a critical point of a function, you can determine if it's the location of a relative minimum, a relative maximum, or a point of inflection by testing points on both sides of the critical point. So the function 2x to the fifth minus 5x to the fourth minus 10x to the third has critical points at -1, 0, and 3. Determine whether each of these critical points is the location of a maximum, a minimum, or a point of inflection. So -1, 0, and 3 are the critical points here. We want to determine if it's a maximum, a minimum, or a point of inflection. So we want to determine if the function is increasing or decreasing on either side of these points. So we can plug some values into the function, right? So f of -1 is going to be 2 times -1 to the fifth minus 5 times -1 to the fourth minus 10 times -1 to the third, which would be -2 minus 5 plus 10, going to be 3. At 0, the function is 0. If we plug in f of 0, f of 3 is going to be 2 times 3 to the fifth minus 5 times 3 to the fourth minus 10 times 3 to the third. Which is -189. So the function can only switch from increasing to decreasing or vice versa at critical points. So if we think about this, if we graph this, at -1, it's at 3. At 0, it's at 0. And at 3, it's at -189. So we can see that it decreases from -1 to 0, and it decreases from 0 to 3. So this is an inflection point. Now, all we have to do is pick points less than -1 and greater than 3 and see what happens. So at, -2, f of -2 would be 2 times -2 to the 5th minus 5 times -2 to the 4th minus 10 times -2 to the 3rd. So this is going to be -64 minus 80 plus 80. So this is -64. So at -2, we're back down here. The function is increasing from -64 to 3, or from, in terms of x values, -2 to -1, the function is increasing. So this is going to be a local max. And then if we pick something like 4, f of 4 is going to be 2 times 4 to the 5th minus 5 times 4 to the 4th minus 10 times 4 to the 3rd. Which is 128. So from -189 to +128, the function increases. So this is going to be a local min. Small business owner employing 15 people hires an analyst to help the business maximize profits. The analyst gathers data and develops a mathematical model. P of x equals 1/3 x cubed minus 34x squared plus 1012x. In this model, P is the owner's monthly profits in dollars and x is the number of employees. The model has critical points at x equals 22 and x equals 46. Determine which, if any, of these points, of these critical points, is a maximum. So f of 22 is going to be 1/3 of 22 to the 3rd minus 34 times 22 squared plus 1012 times 22. Which ends up being 9,357. If we do f of 46, 1/3 times 46 to the 3rd minus 3/4 times 46 squared plus 1012 times 46. And that gets me 7,503. So your maximum is going to be the one that's higher. What does this suggest the owner about business operations? Well, if the owner wants to maximize his profits, he should hire 22 employees. And that's it for 3.6. Stay tuned for 3.7 in just a minute.